Well, thank you. I'm pleased to be here, having been at a previous conference on PIAAC. It's nice to get into this conference, although it doesn't do the cycle 2 of PIAAC, but what we're going to do is focus on the special cycle of Germany, the PIAAC longitudinal survey of Germany, which was in between cycle 1 and cycle 2. I should point out, Lavinia is here, and two absent authors are also on this paper. And what we're asking is a very simple question, is how do skills change with age? And the prevailing assumption is that skills increase for a little bit and then start declining basically after age 30. Some of us objected to that argument, but here's the standard picture that you get if you take all the PIAAC data. These are ages on the horizontal axis and literacy and numeracy scales on the vertical axis. And what you see is after age 30, you ought to start looking for some other job, that everything falls off. And you get the same, by the way, in Germany. Germany's no different than all of the OECD countries. But there's a big problem with doing this. These are all basically cross-sectional estimates. And when you look in the cross-section, somebody who's age 30 is being compared to somebody age 40 with the presumption that after 10 years, the 30-year-old looks just like the 40-year-old. But in fact, they had very different experiences, because what you see is that age and cohort effects are completely intertwined in these cross-sectional analyses. So what we wanted to do is to try to ask whether is it really true that this decline is inevitable, and we'll see it all the time. And we care about it for the reasons that actually Simon introduced last time, is that we think that skills have an important component of labor market outcomes for individuals and for countries, that growth rates, in fact, are affected by skills. And we look around the world and we see countries are aging rapidly. And does this mean that the skill levels are going to cause a drag on the economy over time as countries age? The innovation of this paper is very simple. What we're going to do is to try to look at estimate actual age skill profiles using the special PIAAC longitudinal sample from Germany, where we actually follow the same people over a period of time. And we're going to use those data to try to estimate the full pattern of ages and skills. I'm going to give you the answers in the tradition of doing this, because Simon owns the yellow and red cards. The answer is that if you look at individuals and take out this cohort effect from the cross-section, it looks like skills don't decline till somewhere in the 40s, and literacy skills are pretty flat even after the 40s. Numeracy skills do tend to decline. But it's really important whether people use these skills over their lifetime or not. And if you take into account usage of skills, you find that basically literacy skills never decline for people who actually use these skills. And numeracy skills decline later, and then there's this little funny part that we can't explain very well, and that is numeracy skills for women do decline at age, even when they use these skills. Sorry, that's the answer. So let me quickly go through this. I'm going to skip the related literature part. There's a big cross-sectional literature and so forth. I'm going to skip that and move on to the empirical approach, which is not very complicated except for one thing. We observed test scores of people at two different ages, age A and A star in this example. And the answer is that if there was no measurement error in these tests, all we would have to do is look at the means across these times, put the means together, and we'd have a good picture. The problem is, and our change in skills with age, delta, would be just the difference in the means. The problem that comes up, and I guess we could infer from the morning discussion of the construction of tests, is that there might be some errors in these tests. And the problem with the errors in the test is that when you try to compare individuals over time, somebody who's got a low score in time one probably had a bigger, on average, a bigger negative error to get that low score than he would get, or she or she would get over time. And similarly, at the top end, somebody who looks like they're a top end person could have gotten there by luck or some other thing, answering a couple of questions right on the first test. And the second test, you don't expect them to have the same luck. Luck is uncorrelated over time. And so you get this bias that comes from basically reversion to the mean that comes from the test measurement errors. That's all I'm going to say about this. There's a technical detail, but the problem has been well worked out long in the past of how you might think of correcting for this. And so we're going to correct for that. And so we're going to use error-corrected test scores. And it does make a difference, by the way, in the age profiles that we get. I won't go into it in detail. And then once we've done that, once we've age-corrected all these test data, then we will look at some systematic patterns by behavior or background or other characteristics to try to point that out. So the PIAAC data, it's kind of boring to talk about PIAAC data at a PIAAC conference when everybody is here to talk about PIAAC data, except for the fact that the PIAAC longitudinal data in Germany is a unique sample. No other country did this. I'm going to skip over the PIAAC-1, but the PIAAC longitudinal comes on average about 3.5 years later, where there's an attempt to find exactly the same people, give them exactly the same test under the same conditions, so that you eliminate sort of test differences, you eliminate the cohort differences. They're in the same cohort, you follow them, and then we put it all together. So we get, for Germany, 3,200 retakers that we can use that are taking exactly the same test at 3.5 years later. So the interesting part of this is all the pictures. So let me show you the pictures that you get out of this. What we're going to do first is calculate marginal changes for people by looking at these error-corrected test scores over time. We're going to concatenate all the age groups so that we can get an idea of what is the marginal change in test scores at different age groups. And then we can draw those same pictures that showed everything falling apart at age 30, okay? So here's what you get for the marginal changes. All those little dots are for each age, for each 1-year age group, looking 3.5 years later, what the changes were. There's a little bit of flopping around there. What we do is just draw a quadratic function through all the age points. And we take the answers from that quadratic estimate of the marginal changes to calculate what the patterns of skills by age look like given this longitudinal information on them. And so what you see is that the literacy, those are the gray lines, by the way, the gray bands are confidence intervals, 95% confidence intervals that we calculate. And you see that for literacy, there's no significant change in scores after age 40 to low 40s or something. And so it's kind of flat. For numeracy, we do see that things fall off after age 45 or so, I think it is, and you get a steeper decline. So this is the average for the entire German population, at least our 3,263 version of the German population. But the interesting thing is how these profiles change with backgrounds and skills of the people. One of the historical analyses that's been done is looking at differences like between occupational categories, white-collar workers versus blue-collar workers. And the answer there is it's always motivated by the idea that white-collar workers may in fact sit at a desk and read things more often than blue-collar workers, so that they are using these skills more often, so you might expect different outcomes. Well, one of the advantages of the PIAAC data set in general is that for the initial PIAAC wave, we have very elaborate questions about usage of literacy and numeracy skills. There were sets of questions asking about how often did people do certain tasks, like reading a newspaper. Do you read a newspaper daily? Do you read it weekly, monthly, or never at all? Okay, and so what we did was to put, for both literacy and numeracy, we took 6 questions about different kinds of behaviors to calculate a numeracy score for everybody by just basically averaging across how many people used each skill once a month. So how many people read a newspaper once a month or a magazine? There used to be magazines that were there, and the questions about magazine usage. And so we calculated this and calculated people with high and low usage of both reading and literacy and numeracy. There were questions separately of did you use these skills at home or did you use them at work? We put those together. They're correlated but not completely. So by our measures, about half the people use these different literacy skills once a month. And less than that for numeracy skills. A third of the population uses this measure of numeracy skills once a month. The literacy is done more at home than at work, and the opposite for numeracy, which is done more at work than at home. Again, we put those right all together. I don't think it makes much difference. They're correlated 0.35, 0.4 of home and work usage and so forth. So then you might ask, well, do people who continue to read, this is going to save a lot of you people here, do you continue to read over time? And the answer is yes. Here's the marginal distributions by age of literacy on the left and numeracy on the right. The high usage, the pinks, in fact, are often significantly positive, means skills increase over time in literacy, and the same with numeracy. Low usage people have falling marginal skills after basically age 30. So the way you escape the 30-year-old trap is by continuing to read, okay? And the answer is the following. Here's the pictures. People with high usage of both literacy and numeracy continue to increase up till age 65 when the PIAAC data stops. So you don't have complete data on this. It may fall off. But in general, low usage people don't increase very much from their initial recordings, and then they fall off. Now, we can look at the same by occupations, the traditional way, and you get basically the same picture because, in fact, white-collar workers, by our measure, use these skills more often than blue-collar workers. But I'll show you that even within the occupational categories, usage makes a difference. So that high-usage blue-collar workers do better than low-usage blue-collar workers, et cetera. But you see the same picture. You would also see the same picture by education, where we break it down into tertiary versus non-tertiary education. And you see that with tertiary education, everything looks kind of good over time. With non-tertiary education, you start seeing declines. And then here's the part that we don't really explain very well. It looks like regardless of usage, we'll find out that women have increasingly falling skills over time. The whole picture, in my last 1 minute, I can do it. What we did, since these skills peak somewhere in the 40s, what we did was just draw a straight line through the data from 40 onwards and looked at whether it was declining or increasing, basically. And so we can do that by literacy skills for blue-collar workers. What you see is the pink is always the high usage, and the blue is the low usage, and the black is the average. And so you see that for blue-collar workers, if you use it, particularly in numeracy skills, you get increases in skill levels with age, past age 40. If you don't use it, you see declines in skills. And we can go right down the line. For white-collar workers, you see the same differences where the pink dots are always to the right of the blue dots. You know, there's a question about significance because we're cutting the samples a fair amount here of our 3,000 people. If I look at non-tertiary completers, we see, again, pink dots. Usage, high usage leads to improving performance or flat performance where non-usage is declining. Straight down for tertiary whites. And here's the female picture. You see that even with usage, the pink dots are to the left of the 0 line, means that they're pointing a bit downwards after age 40. So that leads to the conclusions that you already know. The cross-sectional age profiles are quite misleading, and that we, in fact, when we use the actual longitudinal data, which only come from the PIAAC-L survey in Germany, we get a different answer. And we get these two main results, is that things don't look so bad until you're 40 on average. And after that, if you keep using these skills, you're probably going to come out ahead, at least on average. And that there's no inevitability or natural law that these skills decline with age. There we are.
We have about 3 to 4 minutes for questions from the audience.
Thank you, Eric, for this wonderful and inspiring talk. You presented different constructs that have effects on skill decline or skill maintenance, like being blue or white collar, being highly educated or not, using skills or not, being male or female. In your last slide, you compared 3 of them with usage, skill usage. Did you run a regression with all of them, including them? And I was wondering, which is the most important one? In which should you invest? Well, gender probably not. It's not that easy to invest in it, but...
Well, I don't think we've ever run the complete regression with all the interactions. What we've done is run a complete regression that had the different categories in it and usage. And I think my answer is always that usage is the key, and that the others are really sort of mechanisms for getting usage up. You know, if you're a white-collar worker, you have trouble avoiding usage, whereas a blue-collar worker, it's easy to do that. But I think usage is the answer. I forgot to mention, by the way, that for this paper, we have the full age span represented in the authors of the paper. So this is a complete experiment that we're doing.
I'm intrigued by the gender part, being a woman over the age of 40 and using a lot of numeracy skills.
I'm sorry to hear that.
Well. I'm very proud, so it's fine. No, I'm the exception that defies the rule. But I wonder to what extent one can look at, do we have good measures of usage of numeracy? One of the things, particularly in the early years, is movement in space that actually has been cited as a reason why we have an early advantage for boys in the building blocks of numeracy. Could it be that women over the certain age are actually not using not using numeracy in a way that is not well captured by our measures, and therefore that's the real difference that makes up the difference that you do see across genders. They're running less across space and
so
blah, blah.
the questions are pretty simple because you've got to have questions that go across the entire population, basically. So the math questions are things like, do you ever look at an Excel spreadsheet, or do you ever balance your checkbook, which people used to do before Quicken. And so they're pretty simple, and then it's also crude on the frequency of daily versus, and so it's possible that the questions aren't right. Like, my wife never balances the checkbook. But so things like that go along with your point. We're limited by what's in PIAAC.
Okay, unfortunately we have to stop. Thanks so much, Rick, for inspiring talk.